we're going to solve this trig equation that we're given right here, just on the interval from 0 to 2 pi, just to keep it a little simple. All right, so I see this is some trig function squared minus 3 times the trig function minus 2, which is quadratic. So ax squared minus bx minus c, that's quadratic. So in order to keep myself sane when I do this, I'm going to let u equal sine x. You don't have to do it this way, but it does make it a little easier on you. And so my equation becomes u squared minus 3u minus 2 equals 0. Now if I try to factor this, which is, there's nothing wrong with that, we don't have a whole lot of options. And so we can tell right away if it's factorable. That's the only option we have as far as setting up the numbers, because 2 is prime. I can only have 1 and 2 here. So the signs are opposite because that sign is negative. So I either have to have a minus plus or a plus minus. If I do a minus plus, I end up with a positive 2 minus 1 for the middle term, which doesn't equal negative 3. If I make this plus minus, I end up with minus 2 plus 1, which still isn't minus 3. So this is not factorable. So we have to use the quadratic formula to solve it. So I do the quadratic formula. A is equal to 1, B is equal to minus 3, C is equal to minus 2. If you don't know the quadratic formula, just Google it. So the quadratic formula says I'm going to take negative b plus or minus the square root of b squared minus 4 times a times c. The whole thing over 2a. Now if I continue with that mathematics, I get positive 3 here. And if I put this in my calculator, let me get my little machine out. I get minus 3 squared, make sure you put it in the parentheses, minus 4 times 1 times negative 2. And I get a lovely 17. So this is going to be 3 plus or minus the square root of 17 over 2. So that means u is equal to 3 plus the square root of 17 over 2. And u equals 3 minus the square root of 17 over 2. Don't panic with those numbers. Just remember that they're not normal numbers that you find on the unit circle. So we're going to just use a method we learned earlier. The inverse trig function will work here. But let's substitute sine back in. So sine of x is equal to 3 plus square root of 17 over 2. And then sine x equals 3 minus square root of 17 over 2. Remember, when you don't get something standard, you just use the inverse trig functions. And remember how the domain and ranges of inverse trig functions work so that you know how to find all of the angles between 0 and 2 pi. All right, and I'm going to scoot this up a little bit here. So here I have x equals sine inverse of 3 plus square root of 17. Don't estimate that yet. You know, you don't need to. Just do a little bit of math here. You can use arc sine if you want, that's fine. And let's just see what two angles pop out when we use this with our calculators. All right, so on this side I will do sine inverse of 3 plus the square root of 17 divided by 2. Note how many parentheses I have there. I have parentheses around that whole top portion, which is important in order for this to work right. Oh, and I get a domain error, which basically means that there's no solution to this particular one because this number is too big. Remember, it has to be between minus 1 and 1. So I will say there's no solution for this one. Now the other one, I'm just going to go back to this and just change that sign from plus to minus. And I get the number x equal to minus 0.5963. Okay, now technically speaking, this angle minus 0.5963 isn't in the interval from 0 to 2 pi. How do I know that? Well, I know that sine inverse, if I draw my unit circle here, I know that sine inverse is defined from minus pi over 2 to pi over 2. So I know that this angle has to be in this quadrant. So I would rotate down this way, and that gives me an angle of minus 0.5963. So if I want the angle that's actually in the interval from 0 to 2 pi, I actually have to just add 2 pi to this guy, and that'll rotate me around into the interval that I want. So technically this isn't one of my answers, but this is. X equals minus 0.5963 plus 2 pi. And that, again, will start me from here, rotate me all the way around, and put me right where I want to be. So you think about this, 2 pi minus a fraction will make it less than 2 pi. Now there's another angle in the interval from 0 to 2 pi that we haven't thought about yet, and that's going to be in quadrant 3 right here. Has the same reference angle down here, 0.5963. And so in order to get that angle in quadrant 3, I'm going to have x equal pi plus 0.5963. And therefore, I have my two angles that solve my original trig equation on the interval from 0 to 2 pi. Just leave them like that. Don't type them in your calculator or anything, because then it's really clear about how you came up with the angles for your answers.